Okay, so hello everyone. Our next topic will be continuous probability function. Okay, previously we have discussed probability mass function. The probability mass function was a function defined from the domain of discrete random variable, but the continuous probability function is a function that is defined from the domain when the domain is the random variable set and it must be a continuous set, then the mapping or the mapping from the domain, this is the function, and this function is defined from the set of random variables to their respective probabilities. Okay, so if the random variable set is a continuous function, then the probability is called continuous probability function. Okay, now when we call this probability function as a probability density function for a continuous random variable of the corresponding function f of x is called a probability function. That means this is your function. This is a function that is a probability density function defined from random variable to their probabilities. That can be said as a probability density function if the following three conditions are satisfied. First of all, as it is continuous, though, we have to check that it is integrable within the interval minus infinity to plus infinity. The second one is the functional value must be greater than or equals to 0. In case of probability mass function, we have discussed that the f of x value must be positive. Here also the same, the f of x value must be positive, or it may be 0 but can never be negative. Okay, now the total integration of the function f of x is equals to 1. That is the concept of total probability. If any function satisfy these three conditions, then we say that it is a probability density function. If these three conditions 1 2 3, first one is here, the function must be integrable and its total integral value is 1, and the functional value is either 0 or any positive value within the interval minus infinity to plus infinity, then we say that the function must be a probability density function. Okay, and the probability of the random variable x within the limit a and b can be evaluated by using the formula integration from a to b f of x dx. That is the definite integration of the function within the limit a to b. Okay, now we will discuss one numerical. Is the function given below is a density function? So we have to check that it is a given function. We have to check that whether the given function is a density function or not. Okay, so there is given that f of x is equals to 0 for x less than 2. So for x less than 2 the value is 0. For x greater than 4 the value is 0, and within 2 to 4 the value is 3 plus 2x upon 18. And also find probability of 2 less than is equals to x less than is equals to 3. This also you have to evaluate. You have to check that this is a function which is a probability density function or not. If it is a density function, then evaluate this one using the above formula of definite integral. Okay, so we will start solving it. It is given that, let us check the number line. All of you know it's a number line. Okay, and we have to check within the interval minus infinity to plus infinity, and in the given question the total interval minus infinity to plus infinity is divided into three parts. First one is minus infinity to 2, then 2 to 4, then 4 to infinity. For 4 to infinity we have the value, functional value f of x is 0. For minus infinity to 2, it is given that functional value f of x is also 0, and for this one the value is given 3 plus 2x upon 18. Okay, so what are the three conditions? The first condition that we have to check that whether the function is integrable or not. So you know that f of x is equals to 3 plus 2x by 18 into less than is equals to x less than is equals to 4, okay, and 0 otherwise, and its value is 0 otherwise, okay. So it's an algebraic function that you know. It's an algebraical expression 3 plus 2x by 18. And we all know that any polynomial, any algebraic function is always continuous and always integrable. So it is obvious that f of x is integrable. In this interval also it is integrable, and for 0 it is also integrable. So f of x integrable in minus infinity to plus infinity. It is obviously true, okay. Then what is your second condition? That you have to check whether it is positive or not. F of x must be greater than is equals to 0 for all x, okay. So we have to check that f of x is either positive or not. It is given that f of x is 0. It is given that f of x is 0 when x lies between minus infinity to 2 and 4 less than x less than infinity. So within the interval minus infinity to 2 it is positive. For the interval 4 to infinity it is also positive. And now check for the interval 2 to 4. Okay, for 2 to 4 we have 3 plus 2x by 18. It is given. So whenever we consider any value of x within 2 to 4, check for 2.5, for 2.1, 2.1, for 2.9, for 3.9, whatever the value between 2 to 4, that means it is a positive value. You put the value of x within 2 to 4 and what will you obtain? The resulting value f of x. F of x is also positive, so it is also obviously true that f of x is positive for all x. So second part is also proved. Now what will be your third part? That the integration from minus infinity to plus infinity f of x must be equals to 1. How? So let us evaluate minus infinity to plus infinity f of x, that is equals to minus infinity to plus infinity, sorry, minus infinity to 2 plus 2 to 4 plus 4 to infinity minus infinity to 2. In this interval the functional value is your 0, okay. 4 to infinity also the functional value is 0. It is given in the question, and for this the value is 3 plus 2x upon 18 into dx, okay. So this one is your 0, this one is your 0. Just evaluate this one. 2 to 4, 3 plus 2x upon 18 dx, that is equals to, this will be 3x plus x square by 18. Put the limit 2 to 4 and check. 1 by 18 will be taken common. This will be 4 minus 2, 2. 3 into 2, 6 plus 16 minus 4. That is your 12. So that is your 12 plus 6, 18 upon 18, that is your 1. So we have proved that f of x is equals to 1. Sorry, integration from minus infinity to infinity f of x is equals to 1. So the third part is also proved that the total integration will be 1. As the three conditions are satisfied, that f of x is integrable, second condition is your f of x is positive for all x, and third condition the total integral is 1, then we can say that the given function is a probability density function, okay. Now let us discuss another numerical. Find the mean and variance. Find the mean and variance of the following density function. Okay, f of x is given here. F of x is equals to x for 0 less than x less than 1, 2 minus x for 1 to 2, and 0 otherwise. What you have to evaluate here? Its mean and variance. It is already given that it is a density function. Okay, so for the mean, the formula is given by integration from 0 to infinity x f of x dx, because it is 0 for minus infinity to 0, so we will consider only the positive part, 0 to infinity. Now let us break this as a 0 to 1, 1 to 2, and all other values are 0, and evaluate in this way, and check that whether the mean value is 1. This is your process to calculate the mean. Just total integration you have to do. And for variance, the formula is expectation of random x square minus e of x whole square. Okay, e of x is your mean or expectation that you have already evaluated as 1, and this value that you have to calculate. So just put minus infinity to plus infinity x square into f of x dx minus 1. Now x square into f of x is value is x for 0 to 1, 0 to 1 इंटरवल के लिए इसकी वैल्यू x है, एंड 1 to 2 के लिए इसकी वैल्यू 2 minus x है, और दिस वन इज योर e of x whole square. So just put the value and evaluate the integral and check that whether the variance is 1 by 6. Okay, so this is the process to calculate the mean and variance of a given density function. If a density function is given, then how to calculate its mean and variance.